So good morning and good evening, everyone. Yesterday we completed CI/CD part. So till now, how we completed our project? First, we installed manually, and then later we did it with shell script, and later we did it with Ansible, and later we used Terraform, and later we used CI/CD, but with Terraform and Ansible. Okay, Terraform is for project infrastructure automation, Ansible is for configuration management automation, and CI/CD is application deployment. So till now we achieved these things, and finally we have the latest technology, that is images and containerization. That is containerization. Okay, so everything is same as VM, but here the memory of the, now earlier we were calling it as VM, now we can call it as image or container. So the memory of the image or container is going to be very less, so that it is very fast. So very fast, like within seconds, you can create another container, another replica. So that's what we are going to discuss. So the advantages, disadvantages, all those theory matters we can discuss once we complete the practical part of Docker and containerization. Okay. So yeah, so you can read our article also. Meantime, so I have written this article. So this is very simple. Okay, so what are the advantages? Earlier, that like Java, enterprise archive files, web archive files, these kind of files we had in the projects. These are very heavy, like too much memory, and we need heavy servers like WebSphere, WebLogic, JBoss to run these kind of applications. But later, the technology improved and we got Spring Boot, and then we got microservices. Microservices is nothing but uh, dividing the big project into small projects, just like we are using, right? The entire, earlier it was like roboshop.ear, but now it is like cart user. So we divided the project based on the components like user, cart, catalog. So for that small applications, we don't need heavy servers. That's the simple concept. So we started using containers. So container is nothing but just like a room inside a flat. Okay, instead of taking the complete flat for rent and paying too much rent, you can take one single room inside the flat and you will get the common area like living room and kitchen. So that is more flexible in every part for a for a single person to stay. A similar concept. So we our applications becoming very small. Earlier it was a very big application like RoboShop. Entire application is single file like RoboShop .var or roboshop.ear. Okay, so this is all applications here, all components in this. Okay. But later, the technology improved. We divided into the microservices. Now it is like user, cart, catalog, shipping. So these kind of components we divided. So these are simple, small components. We don't need heavy servers. We don't need physical or heavy VMs. So that is why we got into images and containers are lightweight. So if you are using microservices in your projects, and definitely we have to use Docker, and you can deploy into the VMs also, like we did, but that's not the correct actually. So microservices, Docker, and Kubernetes is the best platform to run. Okay. So that is the advantage. Bare metal servers is nothing but earlier we had a physical server like our computer. We had a physical server. We were deploying the applications into the bare metal servers. Now we got VMs. Right? So that is the cloud. Entire cloud is based on the VMs, and now no project is using bare metal. Everybody is either using VM or Docker and Docker images or containers. So in VM architecture, so you know Oracle Virtual VM where you can install it into your laptop. You can run Ubuntu servers inside your laptop. So that is nothing but because of hypervisor. Okay, so you have your guest server like your laptop. Sorry, your laptop is a host. So inside your laptop, you can install hypervisor like Oracle Virtual VMware, and you can run different VMs, Ubuntu VM, CentOS VM, Windows, another Windows VM. Okay, this is the VM architecture. But here, this hypervisor is very heavy software. You have to install it, and then here you will allocate like in virtual environment. For example, your laptop or server, it is like 64 GB RAM and then 10 TB hard disk, for example. So the VM technology is nothing but logically dividing the server into logically dividing a single physical server into multiple VMs. So this is the virtualization. Every cloud is following the same. So what does it mean when you are creating these many servers inside your AWS or Azure or Google Cloud? Underlying there will be a big physical machine like this, 64 GB RAM, 10 TB hard disk. Out of that, AWS in background they are creating one VM and then they are giving it to us. Okay, but everywhere it is in any cloud, the technology behind the cloud is VM. Okay, so logically dividing a single physical server into multiple VMs. So that is the VM technology. For this, you need software called hypervisor. Generally, like Oracle Virtual VMware is one of the kind. Okay, so you will run this, and this software can do this task. Okay, logically dividing a big server into multiple servers. So what is the advantage here? So you can have multiple kinds of OS. You can have Ubuntu, you can have CentOS, you can have Debian, so that you can test your application into multiple OS, right? So instead of creating new servers and getting charged, so you can create multiple VMs inside a single physical server. So and you can test your application very well. So compared to the bare metal, so we got some advantages in a VM. Okay, resource utilization, everything. So these are the metrics you can. 1 second. So these are the metrics you can understand the advantages. So containers, we moved one step ahead. Container. So what we are doing here inside VM, we can run multiple containers. So what is VM? Inside physical server, you can have hypervisor and run multiple VMs. So what are we doing here? Inside VM itself, we can run multiple containers. Okay, so that we can even improve resource utilization. Okay. So earlier, what was happening here? So we have cart one VM and then user one VM, catalog another VM. So we were doing like that. Now inside one VM here, single VM, it is going to be cart a container and then catalog another container. So this is how we are going to do that. So enough with theoretical explanation for now. So we need to feel the advantages through the practical approach. Okay. So that we can do it. So you will automatically understand these advantages. Just going through and reading through these advantages will not convince us generally. So, okay, if you do practically and you can understand the advantages. So, yeah, we can start with Docker now. First thing, we will install Docker in our CentOS 8. Let us launch the instance. Taking Docker. DevOps. Right. This. Two micro is enough. Proceed with the keeping. Allow all. Yeah. CentOS 8 install Docker. So it's very simple. Just let us install Docker. No, it found out. Nothing wrong. Okay. It's fine. Okay. Okay. So issue. Okay, so let's follow the documentation. So just run this yum install yum utils and then add the repo. Docker installation is very simple. Just adding the repo and running yum install. That's it. Okay. Now run this command to install. So that's it. Docker is installed. Now just start and enable. That's it. Systemctl start. Systemctl enable. So now I'm coming out of the root access. Okay, now if you try Docker command, Docker PS, for example. So it is saying permission denied. So you need to do one extra step here. That is, that may not shown here. It's not shown here. So that extra step is you have to add the user to the Docker group. So whenever you install Docker, a Docker group is created. Okay, you need to add your user to that group. Okay, so user mod, hyphen a hyphen g. This is Docker group. You need to add our CentOS. Okay, sudo add, and then you need to exit and then log in again to reflect DevOps 3.2.1. Now, if you run Docker psm command, you are getting the results. So don't forget these steps. You need to add the user or CentOS to the Docker group and log out and log in again. Okay. So now let us understand few Docker commands. So here in containerization, everything is image. Okay. Image is like VM. So what is the AMI we created? So till now AMI, how we took AMI? So we had OS like CentOS 8 OS, and we installed like Node.js or Java or Python, whatever. Okay, and then we install some packages or libraries, and we installed application and we took the snapshot, right? So this is the AMI. So yeah, Amazon mission image or container image, whatever the image, what is the meaning of image is. So you should so the image is nothing but OS plus application runtime and the packages required by application and application. So that is called as image. Okay, so you have to create this image. So it is like complete suit. Image is like complete suit or setup. So you can transfer this image to wherever location you want and you just run it, you will get the application. So that's the same concept we had in AMI, right? So once you took the AMI, if you just run it, you will get the full application running. So same concept here, image, Docker image also. Image is nothing but a OS plus application runtime plus packages required plus application code itself, right? So that is called the image. But the only difference here is this CentOS in VM. So this is very heavy, but in our Docker, it is very lightweight. Okay. The first command we use here is Docker images. The Docker images, it will list down the images in the server. Okay. Right now we don't have any images. Now we will pull the image. Docker pull image name, download the image from Docker Hub. Okay. So now what is Docker Hub? Docker Hub is the location where you have all the images available. So this is where you will have all the images available. For example, if you want CentOS, you have the CentOS image, official image. The CentOS company is creating the Docker image and then pushing it to the Docker Hub. Okay. You can find all official images generally, like Ubuntu. You can find the image. Nginx. Can find the official image. Then what is this Nginx? So Nginx, you know, right? So generally, we have created Nginx AMI also. So how we did? We had CentOS 8 OS plus we installed Nginx and then generally you started and enabled. So we got Nginx AMI, right? So that is how the same Nginx company also what they did is they can underlying OS, it's anything, we don't care actually. So if you have Nginx installed, you don't need to worry about the underlying OS. Okay. Once again. Okay. So similarly, the same way we are going to take the Nginx also created the Nginx Docker image. That is how. So underlying OS can be anything. On top of that, they installed Nginx and published to Docker. So that's how you got the image. Right? You can add any number of layers on top of OS and you can create your own image. The same we are going to do now. Okay. So command Docker pull Nginx. Okay. So if you give this, what will happen? Let us see. It is pulling from library Nginx. From where it is pulling actually? So it is pulling from docker.io. You see this docker.io. Docker.io is nothing but Docker Hub. Okay. So now it is pulling from Nginx. Which version? You can see the tags. If you don't give any version, it will pull the latest. You can see using default tag latest. You can use other tags also. For example, let me just get this one. But how can you pull? Docker pull Nginx colon Perl. Sorry. Now you can see it is pulling Perl version. Now if you type Docker images, you'll get the Nginx image, Perl version and latest. Okay, so both you will get. So syntax here is very simple. Docker pull image name colon version. Okay. So you pull the image. How can you create the container? So image, image is actually static. Container is nothing but when you run image, you get container. Okay. So container is running instance of the image. So you have CentOS 8 image generally we have, and then we have cart image, catalog image, everything we have catalog AMI. So when you run the AMI, you will get the catalog server. Exactly same here. When you run the Docker image, you will get the container. So container is the running version of the image. How can you create the container? Is again Docker create image ID. So now here Docker images, Docker create image ID. For example, let's take this one. So you got the container and you got this container ID. Now, how can you list down the running containers? Docker ps list down running containers. Docker ps. Okay, so it is saying nothing is running, but we created the container where it went. So Docker ps -a, if you see, you can see it is container is created but not started. Docker ps, it will show the running containers. So Docker ps -a, it means all. Docker ps -a, it means all. So list down all containers. Including running, stop, exited, and created. Okay. So how can you start the container? Simple. Docker start container ID. So Docker start, and this is a container ID. Now Docker run ps. You can see your container is running. Means your Nginx container is running. So now let us draw something. So you have a VM. So inside you have Docker container. Like Nginx. So you pull the image from Docker Hub. Yeah, and this is running. So this is Nginx. And this is VM. Now, how can I access this Nginx? So if you install Nginx generally, so how can you access IP address :80? You will get the welcome page, right? Now, how can I access this Nginx running inside VM? So that is through the port forwarding generally. So port forwarding is nothing but, so every server have 0 to 65,535 ports. Okay. Every server generally, server or computer, whatever it is. Similarly, every container also same 0 to 65,535 ports will be there. So now we have to forward the port from VM to container. For example, this is your port interface inside your server. So what I need to tell Docker is, for example, you can select any port. I'm selecting like 8081. If someone hits server IP address on 8081, you can inform Docker, forward this request to Nginx on port number 80. This you cannot change because Nginx always runs on port number 80, right? So this is server port and this is container port. Okay. So yeah, before that, let us, how can you stop? Docker stop and then container ID. Docker piece. So now what we did actually, first we pulled the image, we created container, and then we started container. So we ran 3 commands, but instead of running 3 commands, you can just run docker run, that is equal to pull plus create plus start. Okay. So let me remove everything so that you can understand. So docker images RMI. Okay. Docker images -a-q. If you give -a, you will get all images. -q is nothing but the IDs of the images. Now what I do is docker RMI. RMI is removing the image. So I'm deleting the images. Docker images -a-q. Okay. First, I'm getting the IDs and then I'm passing it to the Docker RMI. RMI is nothing but removing image. Okay. Image is used by stopped container. So a container is already there. It is using that image. So Docker RM is nothing but removing the containers. Docker -a-q. So that what it does is is removing all containers. Okay. So Docker RM is nothing but removing all the container IDs. That's it. And then let us remove the images also. This is removing all the images. You can remove particular image also by giving Docker RMI and then image ID. Removes particular image. Okay. So now we don't have anything. Docker ps -a. Okay, we don't have any containers. Docker images. We don't have any images. Now I give Docker run. So what is this run actually? It will pull, it will create, it will start. It will do everything. Now I want to use the port forwarding also. So what I can do here, Docker run. Port forwarding is nothing but -p, your host port, container port, and then your image. So host port, you can select anything, but container port, it is fixed. Whatever the port that container is using, like obviously Nginx is using 80. So this one is fixed. Docker run -p, and then I will use port number 80 only on the host, and container port is 80. I will give Nginx. So this is the command I will give now. The host port is your wish. You can give anything. Okay. Now it is saying, you can see. So it is not able to find the image locally. It is pulling it, and then it is downloaded and it is running it. Now you can see if I access this in the browser, I'm getting the welcome page. However, how I'm getting is first the request is reaching the host port. The host port I selected to port number 80, right? So port number 80, if you send a request, this is automatically forwarded to the Nginx. If you use different port, obviously you cannot access. Okay, you cannot access. This is how port forwarding you have to do. But now there is one problem. So this is in the foreground. I cannot do anything. I cannot run. I cannot do anything here. Okay. I cannot clear the screen. I cannot do anything because it is running in the foreground. Foreground is attaching. So this runs in foreground and attaches to screen. We can't do anything. I want this to run in background, so I have to give Docker run -t. It means detach. Don't attach, detach the screen and run in background. Okay. So now let us run again. You can see Docker ps-a. So the container, it is exited already. Now, instead of this one, I will give Docker run -t. Now, if you give Docker ps, it is running. Now you can access. Running in the background. Okay. So now a container is running. How can I log in inside the container? Like we will log in inside the VM, right? So that we can access the server. Similarly, I have to log in inside the container. I need to access the file system. How can you do that? That is Docker exec. Exec is nothing but execute -it, generally input and terminal, like interactive, you can say interactive, and container ID, and give bash. Bash on. So now I'm inside the container. You can see. So this is inside the container. You are now with root access, and this is the container. Now just go to your CD etc. You have Nginx, and then I want to create something. USR share Nginx HTML. Now I want to create a file here. You can see you already have index.html. Now echo hello, welcome to Docker hello.html. Okay. So I logged in inside the Nginx, and then I created a file hello.html. Now you can access it. Now you can access this /hello.html. Okay. Now you can see hello, welcome to Docker. You just exit, you will come out of the container. So this is how you log in. So you will get some interview questions usually in this. How can you do the port forwarding? So that is this one, -p, host port colon container port. How can you run it in the background? -d. And then how can you log into the running container? It is Docker exec -it, and then container ID. Generally, you will give bash or sh. Just you will say, you are saying, I need the bash terminal. So these are all about Docker commands. Mostly we use in our daily life. Docker PS, if you see. So what is the name of it? Relaxed alien. So this name, how Docker is generating, it is randomly taking 2 dictionary words. Okay. But if you want some name to your container, you can just give -- name option generally. -- name my Nginx. So what it is saying, port number 80. I'm trying to create another container in the VM, but it is saying port number 80, it's already allocated. So now I'm selecting another port 8080. Now if you just give Docker PS -k, it is exited. Why is it exited? Docker logs and this container ID. Okay, name not found. Generally, this name you will give it in the front. My Nginx. Now Docker PS, you can see, got your name. Now you can access this one also. So this is one Nginx and this is another Nginx. This is two different Nginx servers. Okay, not a single one. So this is another Nginx. Running on again port number 80. But now we have another host port open. That is port number 8080. Now if user access port number 8080 and this container, the request will go. Okay. Yeah, so this is how our Docker commands will work. So these are the commands mostly available, the commands we use in daily, but one or two commands if we encounter, we will discuss while doing the project. So Docker logs and container ID is also, if you want to check the logs. Okay. Now this is different, as I said, port number 8080. It goes to another container. Okay. This one. Docker logs, and this is the container ID. Okay, you can see you got the request from the browser. Okay. So yeah, we will take 5 minutes break. Let's come back at 7:56 and we will discuss the further concept. So if you have any questions, you can take few minutes to discuss this Docker containerization concept. Any questions? Santosh Chawla.
Hi, Shiva.
Yeah, hi.
Yeah, Shiva, port forwarding, regarding the port forwarding, you have to maintain the multiple containers in a single VM. How to segregate those ports, how you particular container to run that one, how you identify the in runtime,
Which one? Host port or container port?
host ports.
Host port, it's your wish, completely your wish. You can use any port.
But container port is always same, right? In any
Container port, it is already fixed and then created the image. Okay, so generally Nginx, when you run Nginx, which port it takes?
Yeah, 8080 or 8.
Nginx 80. MySQL,
Yeah.
it is taking 3306. MongoDB 27017. So those ports are already fixed and they are, once you run it, it is automatically taking control of that port. If you want to change that port, generally before running Nginx, you can do the change in Nginx configuration.
Okay.
So if you want to change, then you change it inside the image. Then you can select different container port.
Yeah, got it.
Srikanth?
Hello. Yeah,
Yeah.
hi, sure. Good morning.
Hi. Good morning.
Yeah, hi. Actually, I have one doubt about the concept of container and Docker image. So, I mean, I saw whatever I mean your YouTube videos and saying about the Docker image and all stuff, but it says that the image is completely, I mean, is with the OS and other packages and libraries and all that, right? So what does it exactly does it make the Docker mesh particularly I mean size to 0? I mean the Docker image size will be how I mean what exactly makes the Docker image less in size even if it has the same packages and same application code and same of the
So this one,
I mean, yeah, there is a dependencies here.
this one base OS.
So okay,
So usually, what
the
is the
base.
size of our Windows? Generally, it is like 2 GB, 2.5, 4 GB, something like that.
Yeah.
But here it is in MB.
Okay. So instead of we are having a separate OS, instead of so we are using the shared OS so that
Yeah. So
that's what
this
we need.
OS, like you will get the OS generally from AWS Marketplace, right? And generally you will download the OS. We cannot develop the OS. We are not OS developers. So we will download the what we are doing. Windows OS we are downloading, and then we will start OS. So when you start OS, obviously it means your laptop is running. So exactly the same concept. Docker image is like static, like
Okay.
your Windows. I downloaded the OS. Just because I downloaded the OS, my laptop will not run, right?
Yeah.
So you have to run Windows image so that your laptop keeps running. Okay. So this is that one. And on top of that, generally you can install the packages, right? Packages and softwares. But here what we are doing inside the image itself, we are install packages. We install application and libraries. That's what we did.
Libraries and dependencies. Yeah.
Yes, that's what we did in the AMI also, right? Amazon Machine Image.
Yes. Yes.
Same thing we are doing here, but the base OS size is very less. If you just see the size here, Docker images, what is the size? 187 MB. What is this
Yeah.
Nginx? The Nginx is some bare minimum OS. Generally, we call it is bare minimum OS because it's very less in size. Bare minimum OS plus Nginx is installed on top of that. So what is that OS? We don't care really. So does the developers care what is the OS their application is running? It's not a matter for them as long as the application is giving the response. Correct? So that is the advantage of Docker. You don't need to worry about the underlying OS. Just worry about your application is running or not properly.
Okay. Yeah, thanks, sir.
Manohar Reddy.
Good morning, Shiva.
Good morning.
Shiva, I try to log in inside the container, try to execute some Linux commands. It's not working for me. So, like VA editor also.
VA editor. Okay. So that's what I said. So let us take this one. Docker exec -it bash. Okay.
Yeah.
Clear is there. That is there. Okay. Few commands you will not get it.
LL not
LL?
Yeah.
LL command not found. Let us see ping command not found. So ping is a general simple command every server will have automatically. But here what I said bare minimum OS.
Oh, okay.
Bare minimum OS is nothing but will not have everything. Only required packages or exist. Okay.
Yeah, okay. And one more, Shiva. How to check how much RAM and CPU utilization?
We will get it. We will get it.
Oh, okay. Thanks.
So that is what I said. Bare minimum OS. We don't expect everything is available inside the container. Only required packages. Some containers they don't even have the clear command. Also, you need to install it if you want. Okay, once the application is running, that is what the immutable nature. You don't need to log into the container, and you generally we will disallow the login and then change it inside the container.
Okay. Thank you.
H1. Yashwant A. Devi Karnati.
Hello, sir.
Hi.
Yeah, thank you. Actually, my doubt is whether Docker use up to testing or production also.
Production also, obviously. If a technology is not in production, then we don't use. What is the use of it?
Yeah. No, when I read the what Docker does means like testing and deploying means maybe is it production or I'm just confused. That's why.
It's everywhere.
Sure, can I
Changes.
speak also?
Yes, Yashwant.
Yeah, we are going to do all this in Terraform, right?
Terraform is infrastructure automation.
I mean, creating Docker containers and all these things.
The Docker containers is not Terraform. Only infrastructure is Terraform.
This
Docker containers we will create through the Docker commands. Generally, we use Kubernetes also.
okay,
That we will just wait for that. How
Okay.
we create.
okay, thank you.
Satta. 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 Okay. Srinu.
Yeah, hi Shiva, good morning.
Yeah, hi. Good morning.
Yeah, I had a doubt on that Docker run command. Can you go to that command once? Docker run pull create that one.
Hmm.
Yeah, pull create start. And before that, you have removed all the images and the containers, right? How it's
Yeah.
taking automatically pulling and creating and starting?
That's what I said. It will pull from the Docker Hub. It will create
Okay,
and then it will start.
you are not mentioning any image here, right? In this command.
No, I mentioned Docker run this one. This is just I run.
Okay.
So this is just I wrote it, but the actual command I run is this one.
Yeah, okay, sure, got it. Thank you.
Suresh N.
Hi sir. Now
hi.
we are pulling the image from the Docker Hub like Nginx. That image will useful whether it is Linux or CentOS or Windows for everything or OS based images are also available.
Yeah, OS based images also available, but generally you don't care. Docker exec hyphen IT. Let us see what OS it is. Yeah, OS based images also available. Now cat etc release. So this is based on Debian. Okay, so this is the Debian OS image. Now let us see something. Docker run -d -p 8082 and 80 Nginx Alpine. So as I said, Alpine is the bare minimum image actually, most maximum 6 MB, like an MP3 song. Docker run -d -p Nginx Alpine. So Alpine is the bare minimum OS. Now if you see Docker images, Docker PS, this is our image. Run this 8082. Oh shit. IP address 8082. So you are getting the same welcome page. Okay, but what is the size? You can see Nginx Alpine how much it is. 47.7 MB and Nginx general image 187 MB. So my intention, I want the welcome page. So it is satisfied with this 47 MB image. Which one I should go with now?
All fine.
So because it's a less memory, but my application is running. That's what I care. I don't care about the memory, whatever. But if it is less memory, so this one is working and this one is working. But as a smart way, I have to select this one because of less in size, so that it will be very fast.
Okay, Shiva. Thank you.
Nagababu.
Good morning. Hello.
Yes, yes, yes.
The host port is changing multiple ports in the real time.
Sorry, not getting your voice.
Is it okay now?
Yes.
I'm asking the host port is changing different ports, right, for port forwarding purpose. When the real time to do the load balancing, how these ports will reroute to the different ports.
The load balancing is not available in Docker. We will go for Kubernetes for that purpose. Okay, that is the disadvantage. We will address that. Okay, just wait for it.
Okay, sir. Thanks.
Okay, now,
Hi, sir. I have one doubt.
yes.
Yeah, what is the difference between image and container?
What I said, container is running version of image. What is the difference between Windows OS and then Windows laptop running? Image is a
like
file. Image is a file.
OS.
Yes.
Okay.
Image is OS. If you run image, you will get the container. It is running. If you don't run it, then how can you access it?
You
So
mean yeah. You mean container ID will create based on image.
container ID, how it is getting created, we don't care. You are getting some ID. You can use one image to start 10 containers. You can use one OS to keep it in 10 laptops. You can use a single OS, right? You can simply copy it into the all laptops and run it.
Yes.
So that's those 10 laptops are running based on one single OS. Similarly, based on one single image, you can run any number of containers.
Okay.
That's what I said. Container is running instance of the image. So yeah, you will get all these questions automatically resolved. These simple conceptual questions slowly. Okay.
Yes.
So yeah, as of now, we have seen how to install Docker and how to use Docker commands. Now we understood what is Docker image, how it is getting pulled, how the container is getting created, port forwarding in containers, and then running in background. So how to list down the images, how to list down. These are very simple and silly commands, right? By seeing the command name itself, you can easily understand. So, yeah. So now the question arises, how to create your own image? Someone created the Nginx image and pushed it. How can I create my own image? And then how can others in my company use the images created by me? So definitely these commands are to use, not to create the images. So how to create image is based on Docker file. So there is a simple thing called Docker file. Again, declarative way of creating images. So Docker file is declarative way of creating your own images. Now, if you just see Docker file, it's a text document, contains all the commands user could call. Yes. Okay. So the summary of this one is, if you want to create your own images, then use Dockerfile. Dockerfile is the declarative way of creating custom images. So there are few instructions. We will learn these instructions one by one to create our images. Okay. So you need to create one repo. Docker files. Okay. I need to create the repo. Docker files public. Yes. Git branch stuff. Git remote. So first, let me write something. Readme dot multi Docker file. So Docker file is declarative way of creating images. We can build the images and we can push to any Docker repository. Okay, so now let us understand. First instruction here is from. So hardly there are 10 instructions. Okay, you can see here first from. What is from instruction here? So as I said, the first thing is base OS. Okay, either VM or image or container, whatever. So everything is based on the OS. So if you have some OS like CentOS, then you can use yum command. You have some other OS like Ubuntu, then you will use apt-get. So first thing, whatever, when you are creating image, you have to write the first instruction, which OS you want. Okay, so that is from instruction. This name is fixed. You have to just keep it as Docker file. Okay, Docker file. The file name is Docker file. The first instruction is from which OS you want. I want CentOS 8 version. That's it. What is the instruction name? And then space. What is the OS and what is the version? If you don't give this, then it will take the latest. Okay. If you give version, it will take this one. That's it. This is the from instruction. Okay. Now let me push. Docker files. So I'm developing here in my VS Code. So you have to build and then you have to run the images, right? So the same way. Like the shell script. In my laptop, I can use any IDE like VS Code or IntelliJ, whatever it is. Okay. So I'm doing in VS Code. I'm pushing to GitHub. And in one Linux server where you have Docker installed. You can install Docker in Windows also, but that's not recommended because Docker containerization and images, these are all the concepts based on the Linux OS, not Windows. Okay. You can install Docker desktop, but that will almost kill your Windows resources. What Windows does in background is they will download one VMware software, they will install. So they will create one Linux server. On inside that, they will install the Docker. Okay. So just remember this: Docker mostly or images and containers runs on Linux servers, not Windows. Okay. But there is a software called Docker Desktop. You can run it in Windows, but in background, so this software runs a Linux server in Windows. So this is not recommended, Docker Desktop, because it will kill the resources of your laptop and it is very slow. So this images and containers is the native technology of Linux and Unix based servers, not Windows based. Okay. So from here, we have the Docker installed. And then you will pull and we will build and then run here. Okay, so this is the first instruction from what is the OS you are expecting and which version. Now I pushed it. So let me clone it. Okay. It clone Docker files from. So you create a Docker file, how to build it. So the command here is again how to build Docker image. Okay, you should have Docker file inside that location wherever you are using it. And the command is Docker build -t. It is for tag. What is the image name and what is the version, and dot represents current directory. So it means in your current directory you have Docker file. So very simple. Docker build is for Docker building the image. -t, you are tagging the image with version. If you don't give that version, it will be considered as latest. Okay. So now let us see this. Docker build -t. You can name it. You can name it. It's your wish. Okay. I'm just naming it as from :v1 version and dot. Now, if you give Docker images, then you got your image from v1 and your image size is 231 MB. So what I did actually, I just rebranded the image. I just downloaded CentOS 8 image and then I rebranded the image. Okay. So this is a simple first instruction Now let us go to another instruction. You will easily understand it. Run. So run is the next instruction. Okay. So what is from instruction now? From is to select base OS. Okay. Run instruction is to install or configure inside base OS. Okay. So what is the purpose of run instruction? Run instruction is to install the packages or to configure the image. So now let us do this Docker file. So, but the first instruction should be which OS? I'm here selecting CentOS 8, right? Now run instruction. This instruction name is run. Now I want to install Nginx -y is mandatory because you cannot wait for the prompt. So now what is it? I selected the base OS. On top of base OS, I am installing Nginx. That's it. Now let us push and then see how it works. Git pull. So now what is the command? Same. Docker build -t. I'm going to tag my image. You can use any name. Run v1 dot. See now what it is doing it. So it is saying it is running install nginx -y. So but it is failed. Cannot prepare internal. No URLs. So what happened is in that base image, we don't have any repos mentioned to install. So we need to run few other commands. Install Docker, install Nginx in CentOS 8. So we don't have the URLs like .repos available inside the CentOS bare minimum OS. So for that, need to run few other commands like yum install EPL or something. Let me CentOS Docker image. This guys are current image. I want to install Sorry. Docker file to install Nginx in CentOS. Okay, for example, let us take this one. This is how Docker file CentOS, and then so these guys are doing through the RPM. Let me do something. I will just run yum update or yum install EPEL. So that's what I said. Bare minimum, they don't enable everything. EPEL release. Okay, let me push and pull. Now run again. She is also not available. Okay, let me take another thing, that is Alma Linux. Okay, so Alma Linux, just want to mention comment. Alma Linux is same as CentOS. So exactly same as CentOS. It's 100%, not even 100%. It's exactly, I mean, you can say 1000% same as CentOS. But there is some story that we don't require to discuss now. Just understand this is same as CentOS. Git pull. Now Docker build, run this one. Okay, now that's it. Now if you see your Docker images, so you have your run and V1. This is 312 MB, because on top of the base OS you install something else, right? So that is that Nginx one. Okay, so now I want to run this. I just installed, but I didn't run it. So how can you run this? So run instruction is only to install or configure. So there is another instruction called CMD. It is to run the container. Okay, CMD instruction. Just see the reference. CMD. CMD, you have to keep only one CMD inside it, run, but you can keep any number of run commands. CMD is the command or instruction that keeps your container running. So this is a popular interview question. What is the difference between run and CMD? Run is the command we use to install or configure the packages or the image, but CMD is to run the container. It will only run at container creation. Okay. Now it is run instruction is running it. It will run at image creation. Okay. Now let us see this CMD. We will get the clarity. Docker file. Just copying this. Okay. Now I want to run this. Generally, how you run systemctl start nginx, right? So this systemctl will not work inside containers. Systemctl will not work. Okay. Systemctl is only for the VMs, not for the containers. Then how can we run it? When you run systemctl start nginx, the command running inside is nginx -g daemon off. For example, so now I am in this VM, right? Now I am installing nginx. So I'm installing nginx in VM, not in container. Now, as I said, systemctl is available inside VM. Systemctl start nginx. System, oh, port number 80 is already using, right? Docker remove docker ps -a-q. Port number 80 is already allocated. You cannot generally remove the running containers. You have to use -f for force. So now systemctl start nginx, systemctl enable nginx. So when you keep this one, what is it happening inside the systemd system folder? Here you will get a service, nginx service. So that is multi-user target.fonts cat nginx service. You can see, so there is a command inside user has been nginx. So this is the command actually running. Okay, so this is the command. It is running the nginx server. Whenever you give systemctl start nginx, this is the command running in the background. Okay, so as I said, systemctl will not work in containers. What we have to do, we have to give that command manually. So how can you give that? Is cmd nginx. Generally it is -g daemon off. Okay, so this is the actual command to keep our nginx running. Okay, nginx -g daemon off. Don't think too much about this. Just understand this is the command in background to keep our nginx running. Okay, so now I have given that. Let me write some hello world, run echo hello, welcome to Dockerfile, a way of creating own images. Okay, so where you have to store generally USR share nginx slash hello.html. This is where I am storing it. Okay, and then I am running this. So this daemon of command makes our container running and attached to the screen. It just answer me something. I installed catalog application. Does it run without I start the catalog systemctl start? So what makes our catalog running all the time? That is systemctl start catalog. So you do everything, but without running this command, your application will not be started, right? Similarly, inside the containers, with this one, this keeps our container busy. This keeps our container running. You have to run it in the foreground. That is this one, running them in the foreground. Just remember this point. While running container, your cmd command should keep your container running for infinite time. Okay. So that's what I'm doing here. When I'm running this system start catalog, so this catalog keeps on running. Okay, this catalog keeps on running. It is running for infinite time until you stop it. The similar way, when you are using cmd command, the command you give here, this should run for infinite time in the foreground. Okay, remember that in the foreground. It's okay, even you forget. So now let me push. Now exit, hit full. Okay, we will just complete this and then we can end the session. Docker build -t cmd colon, I will say nginx. Okay, so now yum install nginx is ran and this one is ran, but cmd is not running. This cmd is not running. Why? Because I said cmd runs at the time of container creation. Run command or run instruction runs at the time of image creation. That is the difference, and it's a very, very popular interview question. Now I want to run this Docker images, Docker run -d -p. Let me give 8083 port. If I don't give -d, 8083, and yeah, this one image ID. Something wrong here. It should be colon. So that's what they are saying. So now it is proved, right? So this cmd is running at the time of container creation and it expects something. That's what we did now. Now you need to pull again. Build the image. So whenever you change something in Docker file, obviously you have to build the image again. Okay. Now Docker images. This is the image. Docker run -p. I'm giving 8083 80, and this is the image. Okay, so actually it is attached to the screen. Now, if you just open 8083, you can see it is running. Welcome to Nginx on Alma Linux. Now, because it is attached to the screen, generally what we have to do, we need to give -t, runs in the back. Okay. /hello.html. Is our is it not running? It's not found. Okay, let us see why it's not found. Docker ps. So this is our image, container. Docker exec -it bash cd usr share Nginx HTML. Oh, I missed HTML here. It should be HTML. Okay, come out of it and then remove the container. So when you change Docker file, you need to build it again. Git pull, build it. Now run it. Docker run. First images. Docker run -t -p 8083:80, and then this is the image. So now you just test this. Now you can see we are getting our image. So now what I did, using Docker file, I created my own Nginx image. How it happened? I selected one base OS. It is mandatory. Okay, you can get it from the internet, and then I installed on top of it. I kept my own HTML, and then I am running it. Okay, so now the difference between run and CMD is run instruction will execute at the time of image creation. Run is used to configure or to install the packages. CMD instruction, it will execute at the time of container creation. It means at the time of Docker run. So that is the difference. Very, very popular interview question. Okay. Now we can stop till here today. Generally. Is any questions? You can raise your hand. Yes, Sai Kiran Reddy.
Hi Shiva, good morning.
Yeah, hi, good morning.
We are using the from command now, Alma Linux and other Linux versions. All these Linux versions are downloaded from the Docker Hub or directly from the internet?
Docker Hub.
Everything is from the Docker Hub only. This base OS. Yeah,
Base
that
OS,
one.
yeah, everything is from Docker Hub. You can use another repositories also. Generally, in companies, you have your own Docker repository inside Nexus. Okay, so you can download from there also. But if you don't give anything, maybe you'll get clarity in next session. Right now, it is downloading from the Docker Hub.
Okay. Thank you.
Any other questions from anyone? Yes, Santosh Avula.
Yeah, Shiva. Hello.
Yes, yes.
Yeah, Shiva, suppose you have to run the Node.js application in Docker file, you won't create. Then what you give the command in command line, CMD command. Same like that?
Node.js, actually, we will use Node.js image itself. Let us take this one. What is it? We have Node.js npm images directly. So if you give that and then you keep it in a particular location, then yeah, it will automatically run. We will see that.
So in that time, no need to run any command CMDs, right? Like package running, any.
So actually, Nginx, do you prefer developing your own Nginx or you use already existing thing?
Existing thing.
So we don't want to create our own images, right? We can directly use the existing one. Similarly, Node.js also. So we will have Node.js images. You have two options. You can have CentOS 8 or Alma Linux. On top of it, you can install Node.js. You can do that. Or else you can use the existing Node.js images. So you don't need to take care of which OS it is. What are the commands to install Node.js? You don't need to worry about that. You just take the base OS as Node.js itself. And then on top of it, you keep your application, then run the server like code like Node.js and then server.js, something like that. Okay. So if you run this Node.js server.js, your application will run. We will see that. Where is our catalog? So this one, Node.js space server.js, this will keep your application running. That's it. Okay, you'll understand slowly.
Yeah, okay.
This is too early. Vinod Kumar.
Hi, sir.
Yeah, hi.
We are selecting base OS as CentOS in the from file, from Docker file. Whereas in run command, we are using, again, we are using from as Alma Linux. Why are we using two from commands?
So actually, I'm doing it from the scratch again. You can directly use here from, and then you can use directly run.
Okay. In single file, we can use all commands like from run command.
So you can use
file.
like this, or you can use this one, run colon v1. So what is this run colon v1? This is this one. What is the run? What is the run image? It has base OS plus Nginx installed already. So you can directly use that. So I'm just showing you the instructions. That's what I'm doing it here.
V1 means already we installed the base OS. We are catching from there.
Yeah, so you can use your images as base OS. That is also it can be done. So this is the same thing can be created as from run colon v1 and these two. Okay.
Okay.
So what I did in the run, actually, I took one base OS and I installed. I no need to do again these two. I can directly use this run image. Okay.
Yeah, sure, got it.
Yeah. So slowly you'll get more clarity. You cannot get full clarity in single session. Okay. We are going to do many things in Docker. We will install our RoboShop also using Docker. Okay. Just as of now, stick to this and practice this. And yeah, if you have more time, you can go on to internet and find out the more Docker resources. So we'll get full confidence. So that's all for today. Thank you so much. Have a nice weekend. See you on Monday session. Bye bye.